This demo will show how Transformer for Snowflake can accelerate pipeline development by swapping out tedious SQL syntax with its intelligent processors. The processors in Transformer for Snowflake allow you to make fewer development errors while building transformations that can adapt to your evolving data. We further simplify things by adding processors with predefined logic that will make it easier than ever to express the logic that you need to implement. We're going to take a look at some processors that will help us do things like define operations on sets of columns instead of individual columns, make it simpler to union discrete data sets of data, create pivot tables dynamically, parse JSON data, and deduplicate data. We'll start with a simple pipeline and do a few transformations. Let's look at a preview of the data to see what needs to be done first. We can see here there are a lot of extra double quotes on the beginnings and ends of these strings, so I know it's simple enough cleanup to use a SQL trim function on each column, but what I'm going to do here is actually even simpler than that. I'm going to add an apply functions processor, which is going to greatly simplify this process for me. Instead of specifying every single column I want to operate on, I'm going to use a regular expression to say include all columns. Now I can simply select the function that I want to use and specify the character I want to trim, and now I can preview the data to see how this worked. We can see the data as it came out of the source and after the apply functions operator where all the trim functions have been applied to all the columns. Let's hop over into Snowsight to see how this looks in SQL. You can see here I've had to add the trim function to every single column individually as well as re-alias the column so that the column name persists. So it's much simpler to do this one time in a StreamSets pipeline that is going to adapt as the data comes in since it does not require specific column names. Let's return to our pipeline and continue building. Now I need to deal with the scenario where a data provider changed the format of the data I'm ingesting, but I still need to retain the history in the previous data. So what I'm going to do in this case is union these two data sets together and use that to process the rest of the pipeline. So I'll add a second origin with the second version of the data to the pipeline. And now I'm going to add a union processor to bring these two data sets together. When setting up the union, you can see that StreamSets provides you an option that makes your life a lot easier by giving you the option to pass all columns. This means that you no longer need to worry about aligning all of the columns in the right order or anything like that. StreamSets is just going to align the columns by name, and then we'll create new columns for any columns that don't exist in both data sets. Let's take a look at the preview of our data. So you can see that in the raw trips data, we've got this trip duration column, and in the raw trips v2 data, we have a ride ID column, and neither of these columns exist in both data sets. So if we look at the preview results of the union, we can see the trip duration column, the ride ID column are both there, and the values are just null where there's no value exists, and the tables have been brought together seamlessly with really very little effort on our part. And if we take a quick look at the apply functions processor, we can see that all the double quotes have still been removed even with these additional columns being added to the data sets. Sometimes we really need to reshape the raw data that we have into a format that's more compatible with what our reporting and analytics tools are expecting. So this is one place where the StreamSets pivot processor can be a real asset. To do a pivot in straight SQL, you actually need to know what the values of your column names are going to be ahead of time so that you can include them in the query. StreamSets tries to make this simpler by allowing those values to be determined dynamically at the pipeline runtime. I expanded on the pipeline we were building before and added this branch here to create pivot tables by month. I created a new column that extracts just the month name because I want to total up the number of rides every month. I selected the pivot column previously created in the pipeline, and I select the auto-calculate pivot values, which means that I don't actually need to specify any values ahead of time for the columns that are going to be created. StreamSets is going to do this automatically when the pipeline runs. Now I can preview the pipeline, and I can see that the values in the month column have now become the column names. And I didn't have to know any of those values ahead of time. Now I'm just going to take a look at two pipelines that are really part of a much larger pipeline doing some prep for a machine learning model. But in this case, we're taking some data from the Snowflake data marketplace and preparing that data to be used in the rest of the pipeline. So interesting thing about this data is that it has some embedded JSON in a variant column in the open hours column, as you can see here, which denotes the opening and closing hours for a Starbucks location on every day of the week. All I need to do to parse this JSON is point the pipeline to the column that needs to be parsed and let it know that I want it to extract all the values recursively so it gets any nested JSON and arrays and creates columns for each of those values. I can even add a field renamer to, rename the zeros and ones to open and close so people understand what those values are. And that's all it took for me to parse a JSON blob whose structure I didn't even know. Now let's work on another part of the pipeline to prepare the data for our machine learning model. We're going to focus on the deduplicator processor. This processor is going to allow us to specify a couple columns that we want to use to uniquely identify a record, and then tell the system how you'd like to sort data to determine which record you'd like to keep when there are more than one record with that combination of identifiers. So let's say in this case, we'd like to know what time the first ride is from every bike station every individual week of the year. Here I have another column transformation processor that I'm using to extract different date parts from the start time of every bike ride. You can see in the deduplicator settings, I'm telling it to uniquely identify the rows by the start station ID and the week of the year. And then I'm specifying a column to sort by, which is the start time and ascending. So this will give me the first ride from every station every week. And when I preview the data, I can see that what once was many records has now been, from the previews you can see here in the source, has now been cut down to just the first ride for each station ID and the week of the year. But if we changed our mind and decided that we'd like to see the first ride for each station by day, we can very easily make that change by going into the deduplicator and updating the columns to evaluate as the start station ID and the date. And it's that simple to just make that quick tweak on the fly and have a completely different result. This was much simpler than using windows and partitions in order to achieve the same result. These are just a few examples of how Transformer for Snowflake can help simplify the process of building pipelines that are resilient to change and easy to understand.